this. Hello, and welcome to this video that covers the topic types of chemical bonding. So, what is chemical bonding and why does it occur? Chemical bonding is basically when two substances combine together in a chemical way. So, they are chemically combined. And why does this occur? It is basically an attempt to fill electron shells to achieve a stable octet. A stable octet is achieved by having 8 electrons, or sometimes 0 electrons, in the outermost shell of an atom. So in order to know and learn more about chemical bonding and their types, we must first know how electrons are distributed across the shells of an atom. So different electron configurations means different levels of bonding. And so in order to understand the sentence, we must know how to distribute the electrons across the shells. So here we have a table that shows the outermost electrons of some atoms in the periodic table. Okay, now, symbols of atoms with dots to represent the valence shell electrons. We must learn that a valence shell electron is the outermost shell, the number of electrons that are there in that shell. Let's take hydrogen as an example. If you go back to the periodic table, you'll notice that hydrogen is located in the first group, or sometimes it is located nowhere, separately from the other groups. However, if you notice that hydrogen has an atomic number of 1, recall that an atomic number is equal to the electron number, which means the numbers of electrons in that atom. So hydrogen has 1 electron. 1 electron means it has 1 shell only. There's no need for another shell. So we represent that electron in a dot on the first shell for hydrogen. Let's take another example. Let's say we have a chlorine atom. Going back to the periodic table, you'll notice that chlorine is in group number 7. Recall that a group number also tells us the number of valence shell electrons, which is the number of shells in the the number of electrons in the outermost shell. And so, going back to the periodic table, you realize that chlorine has an atomic number of 17, which means that also the number of electrons is equal to 17. If you have forgotten the idea of the group number representing the number of outermost shell electrons, you can know the valence electrons by drawing the electronic configuration of the Cl atom. So in order to draw the electronic configuration of a Cl, first we must know the distribution of the electrons, the maximum number of the shell that can hold. So the first shell can hold up to 2 electrons. The second shell can hold up to 8 electrons. And the third shell can hold up to 8 electrons, and sometimes in special cases, it can hold up to 18 electrons. Let's not talk about that and stick to this configuration. Now that we know this stable, fixed electronic distribution, we'll fill the electrons of chlorine. So the first shell can hold up to 2. And so 17 minus 2, we're left with 15. 15 minus 8, we'll draw 8 electrons in the second shell. And so 17 minus 2 plus 8, that's a 7. And so we're left with outermost electrons of 7 in the outer shell of chlorine. This tells us that the valence electrons in chlorine atom is 7 electrons. Now we can use this idea to benefit in the bonding, because bonding only occurs using the valence shell electrons in an atom. So the first type of bonding we're going to talk about is the ionic bond. An ionic bonding is basically the transfer of electrons from one atom to the other. Of an atom. So in order to know and learn more about chemical bonding and their types, we must first know how electrons are distributed across the shells of an atom. So different electrons about is the ionic bond. An ionic bonding is basically the transfer of electrons from one atom to the other. Ionic bonding usually occurs between a metal and a nonmetal by transferring of electrons. This creates a negative charged atom and a positive charged atom. The one that loses electrons has a positive charge, which means an anion has been created. In this case, it's the metal. Usually, it is the metal. And the atom, or the nonmetal, that has gained the electron now has formed a cation, which has a negative charge. And a negative charge means that it has gained more electrons, so that it has become more negative. This results in two atoms with a stable octet, where the atom 2, or the nonmetal, has gained 8 electrons, and the metal, atom 1, has lost an electron, thus has a full outer shell of 0 electrons. We're only talking about outer shells here. Keep that in mind. Thus, after forming the anions and the cations, we now have two oppositely charged ions. An attraction between the oppositely charged ions of positives and negatives. This attraction is called the electrostatic traction, which creates a strong ionic bond. Here is a representation of this electrostatic attraction between two ions. Na plus and Cl minus have formed after Na sodium atom donating 1 electron to the chlorine atom, which gained this electron to become a cation and have a negative charge. Thus, as a result of the negative and positive charges, an electrostatic attraction occurred. If you look through a microscope on the crystals of an ionic compound, you realize the lattice arrangement of an ionic compound inside that solid or a compound, where there are positive and negative ions charged and are attracted to each other and formed an organized structure of lattice. The second type of bonding we're going to talk about is the covalent bond. Covalent bond occurs when an atom of a nonmetal reacts with an atom of a nonmetal. This is by sharing of electrons, sharing a pair of electrons to form a covalent molecule. As you can see here in this figure, you can notice that the two atoms have donated their electrons to share a pair of electrons, and thus each atom has gained a full octet. Each atom has a stable octet of 8 electrons in the outermost shell. And now, the nuclei, which includes the protons, which has a positive charge, is attracted to the electron pair shared in between those two atoms, which creates a very high strength for the covalent bond. That's why a huge energy is required to break down the covalent molecule, thus the covalent bond. However, if I have covalent molecules, a group of molecules covalently bonded to each other, this molecule or compound has a low melting boiling point. This is due to the weak intermolecular forces between the molecules. However, keep in mind, we are talking about the strong covalent bonds, which are within the molecules between the atoms. Thus, that requires a lot of energy to break them. While between the molecules and within the compound itself, there are weak intermolecular forces which are being broken down. Thus, this creates a low melting boiling point for the compound as a whole. In this figure, you'll see a representation of the covalent bonding. As you can see here, the two pairs of electrons have been donated from each atom to be shared by the two atoms. Let's take another example. For example, we have oxygen. And oxygen is usually diatomic. We call that O2. We all know this molecule. It is very common. It is found almost everywhere. O2 is basically two oxygen atoms joined together by a covalent bond. How did this joining happen? This is by the donation of a pair of electrons from each O atom. Referring back to the periodic table, you realize that oxygen has an atomic number of 8, which means the electron number is also 8. And so to distribute those electrons and to know the valence shell electrons at the end, the first shell takes up to 2 electrons. The second shell can hold up to 8. However, in our case, 8 minus 2, we're left with 6 electrons. And so the valence shell electrons are 6 electrons in the outermost shell of each oxygen atom. Let's represent that here. As you can see, there are 6 electrons for each oxygen atom separately. However, once they join, you might see that 2 pairs of electrons have been donated by each atom. So let's cross out this, and let's cross out one of those. Lastly, each atom has gained a full stable octet of 8 electrons. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8 for this oxygen atom. And for this one, 1, 2, 3, 4, 5, 6, 7, 8 electrons for each oxygen atom. And now we have gained a full stable structure of each oxygen atom. Stable octet structure. Going back to the covalent bond, there are several types of covalent bonds. It can be polar and nonpolar. Let me give you a brief description of the polar covalent bond. A polar covalent bond is when a metal reacts with a nonmetal. However, there are slight differences in their electron negativity values, which makes them polar, which creates a charge on the atoms that are covalently bonded to each other. We'll talk about this concept in a video later. Finally, the third type of bonding that we're going to talk about today is the metallic bond. Metallic bonding occurs in a metallic substance, which is a force that holds atoms together in that metallic substance. So the atoms that the electrons leave behind become positive ions, and the interactions between such ions and the valence electrons will give rise to the binding force that holds the metallic crystals or structures together. And so you can see here a representation of this, where there are positive metal ions in the metal and the free moving delocalized electrons that are free to flow through the structure. This delocalization of electrons gives a property of metals where they are good conductors of electricity and heat, as they can carry current through because of the delocalized electrons that can move throughout the metal. Notice here, this is a brief description of how the protons, or the positive ions, and the delocalized electrons would look like in a metallic bond. This creates a strong attraction between the positives and the negatives in the structure, thus forming the metallic bond, or force. Lastly, as we mentioned before, the properties of metallic bonds are strong, and so metals can maintain a regular structure and usually have high melting and boiling points due to the strong attraction forces between the delocalized electrons and the positive ions, thus requiring high amount of energy to break. Let's see examples of metallic bonds. Metals are found everywhere. It can be found in the kitchen, spoons, cars, and even furniture. Look out for those objects in your day-to-day life and point them out. And remember, metallic bonding. Lastly, thank you so much for joining me in this video. This is STEM Enrichment 2. If you haven't subscribed to the channel, please do subscribe down below, share, and like the video, and comment down below if you have any questions. Thank you.